Chapter 4, Problem 7. A firefighter of mass 80 kilograms slides down a vertical pole with an acceleration of 4 meters per second squared. What is the friction force that acts on the firefighter? So what we would have here is the mass of the firefighter is 80 kilograms. What we also know is that he accelerates down at 4 meters per second squared, which means he's not in free fall. If he was in free fall, according to his weight of Fw, his weight of 800 newtons, right? 80 kilograms times 10 meters per second squared, then he would be accelerating downwards at 10 meters per second squared. But he's not, because there is of course friction on the pole. So this one up, and which we're supposed to figure out. And the way to do that is to say, okay, we have a number of forces that equals mass times acceleration. And one of the forces we don't know, the frictional force. Another force we do know, and because it's going down, I call it 800 newtons, downward minus 800. And that equals 80 kilograms. And that times, need a little bit more space, 4 meters per second squared. But just like the force, his weight being downward, his acceleration is also downward, so I should call this a negative here. Okay, let's see what we get. The frictional force minus 800 newtons equals negative 320 kilograms meters per second squared, which is also newtons. And now we add 800 newtons to the other side, and we come up with a positive 480 newtons. You can do that on a calculator. Negative 320 plus 800 is 480 newtons. So that's the force up. That also makes sense. It's quite a bit smaller than 800, so we probably do come up with an acceleration of 4, and we can check that. 800 minus 480 is 320. That force is still downward. Divide 320 newtons by his mass is the given 4 meters per second squared. So what I just did in mid-air here was a check of our answer. Chapter 4, Problem 9. Sprinting near the end of a race, a runner with a mass of 60 kilograms. About 130 pounds, accelerates from a speed of 6 meters per second to a speed of 7 meters per second. So he is first here at 6 meters per second, and then he has accelerated to 7 meters per second. A, what is the runner's average acceleration during this time? Oh yeah, and it says in 2 seconds. In 2 t equals 2 seconds. So they're asking in part A, what is the acceleration? Well, from a previous chapter we know that the acceleration is change in velocity over the time interval. So a change in velocity would be 7 meters per second minus 6 meters per second divided by the time interval of 2 seconds. 7 minus 6 is 1, divided by 2 is 0.5, and the units are meters per second, so meters per second squared. Okay, second part of the problem says, to gain speed, the runner produces a backward force on the ground so that the ground pushes the runner forward, providing the force necessary for acceleration. Calculate this average force. I need a little bit of space here, so I'm gonna see if I can move the stuff out of the way. Okay, so there is a force backwards that the runner exerts on the ground, and therefore there is a reaction force that the runner experiences of equal magnitude but in the opposite direction. So the runner pushes on the ground backwards, and the ground in turn pushes on the runner forward, equal and opposite force. The two are equal to each other, and now the question is how much of a force? Well, the runner accelerates at 0.5 meters per second squared. The runner has a mass of 60 kilograms. We're supposed to figure out the force, so we're back to Newton's second law. Force equals mass times acceleration. And so we have force equals 60 kilograms times 0.5 meters per second squared. And therefore the force is 60 times 0.5 is 30 kilograms meters per second squared is newtons. Notice that the weight of the runner is not figuring into this formula because we're talking about the forces, or the force, in the horizontal direction, and the weight is in the vertical direction, a weight of 600 newtons, which, by the way, is cancelled by the support force on the ground on him, also of 600 newtons up. But those two forces are in the vertical, while here we're talking about the force in the horizontal that accelerates them along the horizontal.